Hello guys, welcome to today's class on mathematics. So we are going to be looking at sets. Okay, set is one of the fundamental topics in elementary mathematics. Now in sets, we normally use this symbol to represent a set. It's a kind of coil bracket, okay, such a way that we call this the brass. Okay, so it's in a coiled form. Alright. So most times we use capital letters to show this particular set. Okay, so you can see the set of this with what we call the elements in this set. Now these elements, we call them the elements, or we can also call them the entries. Okay, so these are the elements or the entries. These are the elements or the entries of set B. So we can read this as set A is equal to a particular set with elements A, B, and C. Alright. So now how do we describe this set? How do we describe the set? So in the description of sets, we can do that in three different ways. Okay. So the first one there is the set builder or the set form. Now for the set builder, we try to form a set by considering a particular property for a particular for a set. Okay. So such that, for example, if we have W is equal to this particular set, okay, we read it as is equal to X such that X is the day of the week. So when you see such set, you can see the set of X. Okay. So such that X is the day of the week. Alright. Now we also have the other form of representing the set, which is the rule method. Now for the rule method, for example, we have that W is equal to the days of the week. So we strictly go to the particular form that we are looking for. Okay, so it's just different from this where you have to go to the X variable, then you now say what the X variable is all about. So for here we go strictly to the concept of that particular set, so that such that W is equal to the days of the week. So the other one is the listing or the roster method. Now for the listing or the roster method, from the word listing, we list this particular elements, okay, in the set. Now if we look at this, that W is equal to Monday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So these are the days of the week. But this time, in representing this set, we are listing them. Okay, so we call them the roster method or the listing method. Alright, so we have properties of sets. Okay, so we are going to be looking at these different properties of sets. Now the first one there we have is the membership of a set. Now for the membership of a set, we talk about the elements of a set. Okay, so just like they say, if we have set A is equal to A, B, C, and D, okay, then the elements of set A are A, B, C, and D. So we can denote this as A. We can use this. A is elements of Of A. Someone can write that B is also element of A. C is an element of A. Or you can still write D is an element of Of A. So these are the elements of this set. So we use this symbol to show the element of a set. Now, if you look at this, let's say we put 1 here, you can't say that 1 is an element of A, because 1 is not found in this set A. Okay, so we write that 1 is not an element of A. So we use this symbol to show that this is not an element of A. So you can still see that A is not an element of what? A. Okay, you can see that F is not an element of what? Of A. Okay, so this is all about the membership of a what? Of a set. So we talk about the elements and those that are not elements of that what? Set. Alright, so the next on the list is the equality of a set. Okay, now for the equality of a set, from the word equal, okay, we are talking about sets that are what? Equal. Alright, so if I give you set A to be equal to A, B, C, and D, okay, and I give you set B to be equal to C, A, D, and B, okay. Now if you watch very closely, you see that the elements that we have in A, okay, in set A are A, B, C, and D, and that we have in set B are C, A, D, and what? And B. Okay. Now the same elements that we have in A is just the same as that which we have in what? In B. Are we together? It's just the same as that which we have in what? In B. The only difference is just the what? The arrangement. Okay. Just that here our C is found somewhere here at the third position, but here our C is at the first position. Okay. But that doesn't really matter. What matters is the elements. Okay. If they are the same elements we have here, are just the same elements we have here. So because of that, we have A here, we have A here, we have B, we have B in the set here, we have C in the set here, we have D, we also have D in the set here. So that means that A is equal to what? To B. Okay, so we say that A is what? Equal to B. Now another important thing about set is that the repetition of elements do not really what? Matter when we come to equality of a what? Of a set. So for example, you can see that set A, B, C is just equal to set A, B, what? C. Okay, so you see we have A here, but here we are having double A. Okay, here we have B, B, and we have also C and what? And C. So the point here is that the repetition of this set does not change the fact that these two sets are not what? Equal. So we say that the sets are what? Equal. That's why in set we do not repeat what? Elements. Okay, because these two, they are what? Just what? Equal. Alright. Now the next one on the list is the empty or the null set. So it's either we call it the empty set or we call it the what? The null set. Now let's look at it here. The empty or the what? The null set. Okay, so in this kind of set, from the word empty, they are sets that do not have what? Element in them. So such sets will refer them as what? The empty sets. Okay, so for example, I give you set C is equal to this. Okay, this is a type of what? An empty word set, because you can't see any word elements, okay, in this word set. Sometimes we use this symbol here to denote what? Empty word set. So you can see that A is equal to what? This. This means that A is an empty word set. Or you can still see it this way, like C is equal to this. C is what? An empty set. Okay, so this is all about the null or the empty set. Now if you see something like this, K is equal to this, then you see this. Is this an empty set or is this a null set? Okay, so how do you know? Now this is not an empty set because of this. Okay, we are having another element or entry into this word set, which does not define the word the empty set. So this is not what? An empty set. It's typically that it has an element or an entry, phi, or this symbol here. Okay. Now the next one we have is the subsets or the supersets. The subset or the superset. So let us look at the subsets supersets. These are two different types of sets, the subsets and what? The supersets. Alright, so now for the subset, we use symbol like this to denote subset. Okay. Now if I have that A is equal to 1, 2, 3, okay, and I have that B is equal to 1, 2, 3, 4, 5. Okay. Now you see that all the elements we have in A are just in what? In B. Okay, so it's look as if B is producing what? A, and A is gotten from what? B. Alright, so we say that A then is a subset of what? Of B, since A is gotten from what? From B. Then in the reverse, we say that B is a superset of what? Of A. We use the symbol to show what? The superset, okay, of A. So you see that B is producing what? A. So it's the what? Superset of what? Of A. Alright, so that is all about the subset and superset. Alright, so if we also look at the next one is the power law. So for the power law, or the power of sets rather, we have that if we look at a set, let's look at the set K. Let's go to set K and say that set K are set of elements 1, 2, and 3. Okay. Now the power of the set is the number of subsets. Is the number of subsets that found in what? In K. Okay. So we say that is the power of set what? K. So if we want to list out the numbers of subsets that you can see here, such include like the empty set is part of a set, okay? Then we have 1 as another, we have 2, we have 3 as another, we have 1, 2, right? We have 2, 3, we have 1, 3, we have 1, 2, 3. Okay, so if you want to pick another one, I think there is no other subset here, because all you will do now is to be interchanging. Maybe you write 2, 1, it's still the same as this. Okay, so we don't take it again. From equality of sets, you have seen that both of them are the same. Now, the thing is this: we count the numbers of subsets we have here. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 subsets in K. Okay, so that makes the power of set K. We write that the power of set K is equal to what? 8. Okay, so you can have more complicated ones. Maybe they gave you Q, that Q is equal to 1, 2, 3, 4, 5, maybe A, B, and so on. Now you see that you have to also break down this into different sets and subsets to get the number of subsets, which is the power of the set. Now you don't need to do all this breaking down. With this formula, 2 raised to power n, we can calculate the power of the set. So what is n? N is the number of elements, or you can call it the cardinality of that set. So this number of elements, like 1, here we have 1, 2, 3. We have 3 number of elements. We have 3 elements here in this in set K. So what we do is that we are going to write that this will be 2. Instead of writing n, we know we have 1, 2, 3, which is what? N is equal to 3. So this will be 2 times 2 times what? Times 2. So 2 times 2 is 4. 4 times 2 is what? Is 8. So this gives us the same answer as this one here. Okay, so we have that 8 is the is the power of the of set K, which is the same as this. So with this formula, you can calculate the power of the set. Now, if you look at this other one, let's say, okay, do this, P is equal to 1, A, 2. Alright, so what's the answer? Okay, now, you see we have 1, 2, 3. We have 3 elements in this word set. Okay, so we also have that our answer will be equal to what? 8. Just like this, we also have 3 what? Elements. So don't make that mistake to say we have 2 elements. No, we have what? 3 elements in this word set P. Alright, so the next we look at is the difference of a set. So for the difference of the sets, from the word difference in mathematics, what do we talk about? We are talking about what? Subtraction, right? Whenever you see difference in sets in mathematics, you're talking about what? Subtraction. Alright, now in the difference of a set, we might have a set A equal to A, B, C, and we have another set B equal to C, D, F. Okay. Now, if we look at this set A and B, and we are asked to find A minus B, sometimes you can also be asked to find B minus what? A. Okay. So what we are going to do here is, since we are starting with A minus B, we look at the elements that are in A, but they are not in what? In B. Okay, so once we get that, that becomes the difference of A minus what? B. So if we look at this, we have A, B, C. The elements that are in A, but they are not in B, we have A, B. We don't have A, B in the set. We have C here, so we don't pick it. So we have A, B. A, what? B becomes our answer. Alright, so that's the difference of A and what? And B. Then for the difference of B and A, so this time we look at the elements that are in A, in B rather, and they are not in what? In A. So those elements that are in B that are not in A gives us the difference of the what? Of B and what? And A. So I have C here in B, I also have it in A, so we don't pick it. I have D here, I don't have D here, so I pick what? D. I have F here, and I don't have F here, so I pick what? F. So this becomes the what? The difference of the what? Of the set. So that's all about the difference of a set. Now the next is the intersect of a set. The intercept of a set, or we can look at it as the intersection of what? Of sets. Now we use this symbol like N, okay, to represent what? The intercept of a set. So if we have that A is equal to, we have K, I, J, and we have that B is equal to I, A, C. Okay? Now we are asked to find A intersects B. A intersects B. So when we talk about intersect, what comes to your mind is what? Common. Okay? Those things, those elements that are common in A, that are also common in what? In B. So those elements that are common in A, that are common in B, becomes the what? The intersect. We have K here, we don't have K here, so we don't pick it. We have I here, and we have I here. They are what? Common. So we pick what? I. We have J here, and we don't have J here, so we don't want to pick it. So what we have is just A intersect B is equal to what? I. Also, that means that if you look for B intersect A, you also see that B intersect A is also equal to what? I. So therefore, we can say that A intersect B is equal to B intersect what? A. Okay. Okay, so that is all about the intercept of a set. Now, for the next one, we have the union of a set. The union of a set. Now, when we talk about the union of a set, what comes to your mind is what? Combining. Okay, joining together. Okay, that's the union of a set. Now, let's say we have a set K to be equal to these elements 1, 2, 5, and 6. Then I have set G is equal to 3, 4, 1, and 6. Okay, now I'm asked to find K union. Okay, let's do that here. I'm asked to find K union G. Alright, so we use this symbol U to show what? The union of a what? Of a set. So if we are asked to find the K union G, we are combining. We pick the elements that are here and combine it with that are here. But remember, in set, we do not repeat same elements. So here we have one here, we have one here. We can't say here is what is, we just pick one of the one, okay? So if we also look here, we have 2 here, okay? We pick 2. Here we have 3, we can pick 3. Here we have 4, we can pick 4. Here we have 5, we can pick 5. And we have 6, we also have 6, we can pick one of the 6. Okay, so I just arrange them in your counting numbers, okay, so that you have 1, 2, 3, 4, 5, 6 as the what? As the union of the what? Of the set. So a union of the set, you are combining these what? Sets together. Alright. Now the next one here is the universal sets. From the word universal, okay, we are looking at the overall what? Set. Now, any set can be the universal set, depending on the system and the subset it has. Okay, so if I consider U to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, then I have set A is equal to 1, 2, 3, okay, and we have set B is equal to 4, 5, 6. Alright, so we say that U here is the universal set of A and B, because A is gotten from what? The universal set, and also B is also gotten from the what? The universal set. You can find this element in what? The universal set. You can find this element in the universal set. Alright, then for the prime of a set, which is the last one we look at, we are now calling the prime of a set. Now let's use this example here to explain the prime of a set. The prime of a set here is those ones that are in the universal set, but we can't find it in the what? In the subset. Now we say that A prime or A complement will be sets that are in the universal set but are not in what? In A. So we have 1 here, 2 and 3, they are all in what? In A. But here we have 4, 4 is not in A, 5 is not in A, 6 is not in A, 7, 8, 9 and what? And 10, they are not in A. So we call this the complement or the prime of what? Of A. Then of course for B, B will be what? The prime of B, or you can say the complement of what? Of B. So that we write that here we have 1 is in the universal set but is not in B, so we pick 1. 2 is here and is not here. 3 is in the universal set and is not in B. Okay, then we have 4, 4 is also here, 5 is here, and 5 is also here. We have 6 and 6 is also here. Here we have 7, so 7 is not in B. We have 8, 8 is not in B, 9 is not in B, and 10 is not in B. So this gives us the word, the prime of a set, or the complement of a set. Okay, so we are going to end the class here on property of a set. So in our next class, we are going to look at the Venn diagram, okay, and see different question or aspects of the Venn diagram. Alright, so thank you very much. So this is where we end the class for today. Now, if you have not subscribed to the channel, I would love you to do that, and make sure you also click the notification bell there so that you get updates of series of videos that will be coming from the Michsurd Academy.